Now let's look at an example of input-output control. So input-output control is a rolling chart of input, planned input and actual input, planned output and actual output. So at any given point in time, so you'll have planned values, okay, like that. So you'll have planned input, jobs coming in, so these may be in machine hours. 400 hours of jobs are expected to come in week 1, 380 in week 2, and so on. And similarly, here you have the planned outputs that are expected to come out of the workstation for each of the weeks. Now, as the actuals come in, so this will be the one that you will fill out after the week is completed. Now, if the actual input that came in is 350, then the cumulative deviation is you take the previous cumulative deviation, here let's assume that it is 0, plus actual minus planned. Okay, so actual minus planned, so this gives you minus 50. So at this point in time, the actual input is running below what was planned by 50 units. Okay, let me write a small formula for this. So we have cumulative deviation for week T, for example. Okay. So that is equal to cumulative deviation for week T minus 1. So that is the previous cumulative deviation. Then to that you add the actual input or output. So we're going to be doing this for output also. For week T minus planned input or output for week T. So this will give us the cumulative deviation as we go through 1 week at a time. So continuing to week 2, so at the beginning we have 380 planned for week 2. At the end of the week we have 390 as the actual input. So the cumulative deviation is minus 50 plus 390 minus 380. This gives us minus 40. So we continue in the same way for week 3. Minus 40 plus 400 minus 410 gives us minus 50. Then minus 50 plus 370 minus 370 gives you minus 50. So you plot this and then you can see how the planned input versus the actual input is performing over time. And we do the same thing for output. So we start with 0, previous cumulative deviation, plus the actual output minus the planned output. So gives you, so the planned output is running 30 units, usually it will be in machine hours, lower than what we were planning. And then minus 30 plus 400 minus 400 gives you minus 30. Okay. And then minus 30 plus 380 minus 400 will give you minus 50. minus 50 plus 400 minus 370 gives you minus 20. So now let's look at backlog. So backlog for a given week, backlog for week T, any week T, is you take the backlog for week T minus 1, that is the previous week, plus actual input minus actual output. So backlog is about what is actually happening. So it is not about planned input or planned output. So it's always with actuals. So because of that, you need to note backlog can never be negative. So if you end up with a negative backlog, then you know that you made some mistake somewhere. So we have 80 previous backlog plus, remember the actuals, the actual input. Actual input is the amount of jobs that come into the workstation. So the actual input is 350. And what is actually getting out is 380. So the backlog now is 50. From 80 it has come down to 50. Then 50 minus, once again remember the actuals, 390 minus 400 this further goes down to 40. Then 40 plus 400 minus 380. So there is now more input than output, so backlog goes up. Then 60 plus 370 minus 400 gives you 30. So this is how backlog is calculated, and you can plot the backlog and the cumulative deviations with time as the x-axis, and you can have a visual picture of what is going on. And this chart is very useful in terms of keeping track of what is happening in a workstation and whether an intervention is necessary, especially when the backlog is increasing steadily. So that means there is something going on, and maybe there is not enough output coming out than what was expected, or maybe there is too much loading going on into the workstation and some corrective action may have to be taken. So this is a monitoring tool and a very useful one at that.